Hi everyone. So this week we're going to talk about how to do some basic quantitative analysis for giving context to the figures, the data that we're using, and basically allowing us to use it in a meaningful way as well as represent it in a meaningful way visually. So to start out, we are going to, what we're going to talk about primarily in the sort of most basic, or not the most basic actually, the most basic kind of quantitative analysis we often do is counting. But beyond that, when we're thinking about context, we're going to think mostly about measures, what we call measures of central tendency, specifically mean, median, and mode, and then deviation, how far something deviates from a measure of central tendency. So obviously to do this, we need to have a data set, and so I am going to look at the number of refugees that have been admitted to the US by year. So obviously at the beginning, obviously in January, there was kind of a lot of discussion about the number of refugees that were, the executive order to limit the number of refugees admitted to the U.S. It had just been extended. So how does this compare to the number of refugees that we've admitted historically? So this is a chart by the Migration Policy Institute, I believe, which very helpfully for us, although we could try to extract the data from this chart, actually has a link directly to the data source. It's an Excel spreadsheet. I expect that many of you are familiar with Excel in some way, so I'm not going to spend too much time on the details of working with Excel. I mean, we will do these exercises mostly in Excel, but obviously if you have questions, let me know. Just as a point of reference, Excel obviously is proprietary software. If you're looking for an open source and free alternative, I highly recommend LibreOffice. That's Libre Office. It affords the same functionality as Microsoft Excel with minimal differences in sort of the way that we create formulae and things like that. So if I can get this spread out. So what we're going to do in this exercise is we're going to just kind of pose a couple of questions, which is basically, how does the annual ceiling, the fiscal year ceiling, which I think it's important to actually have to double check this, but if I recall, the fiscal year is not an obvious, is non-obvious. I think it starts in October or something like that. So we need to check on that, obviously, when we start thinking about this. But what is the ceiling? What has the annual ceiling been? And you can see that this goes right up to 2016. As a point of comparison. And so the reason for thinking about this is that it lets us frame things like the recent executive order historically and contextually and say, okay, well, 50,000, how does that sit in context of how many refugees the U.S. has admitted historically. Also, you'll note that we have here two figures, which is helpful. One is the annual ceiling, the other is the number of admitted refugees. And just even eyeballing this, we can see that often the number of admitted refugees falls very short, at least in the beginning. And so what is the difference between the number of refugees that could be admitted? We can see that 2016, it was very, in recent years, it's been very, very close to the cap. And in some previous years, it's been actually well below it. So it'll be interesting. I mean, this in itself kind of presents a story. So this is obviously a highly formatted spreadsheet. I am going to go ahead and copy this to a new sheet just because I find it a little bit easier to look at. And so now, depending on the version of Excel that you're running, this may look a little different for you. This paste special function, which I think is a little outdated actually, one thing that it does is that it can allow us to ignore things like the formatting. So without this, I think, yeah, see, again, their layout isn't bad. I find it a little bit easier to look at it like this. Okay, so it's just a little bit plainer. Now, actually, one thing that you can see is that, so if you look at this, I'm going to go ahead and pump up the zoom level here. Maybe let's do a zoom just so that it's a little bit easier for you all to see what's going on. So I'm going to go up to 150% here. you can see that the figure, this is important, right? That actually the number that is appearing in this cell is 231700. It's a raw number. It's actually a number. But the formatting, what we're seeing here, this with the comma, is due to the formatting within Excel. So if I were to go to Format Cells, I could actually change this. It's been set to include commas here. But I can also change that to be kind of straight numbers. So again, what we're going to be looking at with this is measures of central tendency. There are two that are probably going to be the most common, and we're going to talk about, importantly, we're going to talk about when you use each of them. So the first one is probably very familiar to many of you. It is the so-called average, okay? So the word average we often use to mean kind of typical or usual or expected. In many cases when we use the term average, average is also used to describe what we call the arithmetic mean, okay? So the mean is a specific measure of central tendency, and this is one that you are probably familiar with, even possibly from grade school, and it is add them all up and divide by the number you have. So if I need to calculate the arithmetic mean of something, there are formulas in Excel for this, but I'm going to demo the, I'm intentionally going to demonstrate during this lesson, I'm going to demonstrate how to do these from scratch, and we'll talk about why we're going to do that. So the first thing that I do to get the arithmetic mean is I'm going to use the sum formula, and sorry, this screen is blinky sometimes, and I'm going to select all of the values for which I am looking for that I need to add up. And so I can say there's the sum, and then I'm going to divide by the number of entries that I have. So in this case, one way that I like to do this in Excel is if I hover, actually, is it this way? There's one way where it will give me the count. Ah, yes. So you see if I'm holding this down, hopefully you can see that little yellow box in the corner, and it says 37 rows. That means I have 37 entries. Obviously, I know that I'm starting in 1980 and going through 2016, so that's another way to calculate that. And so now with this sum B2 colon B38, by the way, that's if you wanted to type it directly, that's how you say the sum of everything between two cells. I'm going to use the slash, so just kind of a normal dividing, and I'm going to say divided by 37. Okay, and that is my mean. We're dealing with whole numbers here, so it's a little bit straight, it's kind of straightforward. The one thing I'll point out is that if I were to format this, let's say I gave it and I said I'll give everything 2 decimal points, right? So what you're going to see here is that the mean as calculated, right, is going to go, actually says 95856.76, and if I go back and I say forget the decimals, right, it's going to round this up to 95857. Okay. Now, obviously, so two things to point out here. One, in Excel, the underlying values are not changing here. It's just what the program is showing me, right? So the data remains at the same precision. However, one thing to look out for is not only does 0.76 people not make sense as a potential average, we cannot gain precision through doing arithmetic, right? So what does that mean? What that means is that this idea that the mean is 0.76. Well, the most precise number that I have available is actually rounded to a whole number, right? I mean, again, makes sense because we're talking about humans here, but this would be true even if I was talking about, say, dollar amounts, right? Or currency or something where the idea of a decimal point makes sense. If I add things up and divide them, of course, that we can carry division to, some number of places, right? 2 or 3 or 4 or 5 or whatever it is in many cases. However, when even though division will produce additional decimal points, I cannot report that as a result. And the point is simply that it's because my result can be no more precise, aka have no greater number of decimal places than my original figures do. In fact, it should have one less. In this case, we round out to a whole number, and we end up with 95857. So this is the arithmetic mean. It's very straightforward. In this case, if I want to do the arithmetic mean on the next column, I can actually just paste this over. We saw that a few weeks ago, that if I have a formula in a given row that references cells in that same row and I copy it down, then it will intelligently kind of shift the references down each row. In this case, the same thing happens with columns. I've referred to I've referred to cells in a single column. It's the same column that I'm in. So if I move that formula over one, it will do the same and move those columns over one as well. Our next measure of central tendency is the median, okay? And the median is a different way of thinking about the center point of a set of values. And the way that we, while in the case of the mean, we can calculate the mean no matter what order our numbers are in, right? So, these, by default, we got these in chronological order, which makes sense in the way that we tend to think about these things. But we want to evaluate the values that they have. For the mean, it doesn't matter because, again, we're using, multiplication and division, or, sort of whatever it is. They're irrespective of order. It doesn't matter the order of operations there. Although actually we're adding and dividing. But when it comes to the median, order does matter. And specifically, we need to be sorting our data from, we're going to do it smallest to largest. It needs to be either largest to smallest or smallest to largest. It doesn't matter, but we're going to do it smallest to largest for convenience here, or just for consistency. So I'm going to come up to data here, and I'm going to choose sort, and I have to choose this. I'm going to choose custom sort just because I find it easier to deal with. And so what this is going to say is, okay, what do you want to sort on? And in this case, I want to sort on, it's actually given me the names of the columns. I'm going to sort on values, smallest to largest. I hit OK. And so now what you can see is that my years are not in order anymore. That's all right. But my annual ceiling values are. Now, this is important because what I'm trying to figure out is what is the midpoint, okay? So what the median tells us is not what the quote-unquote average is. It tells us what is in a data set that has a certain number of readings. In our case, we have 37. It says, okay, well, what is the value of the middle reading, the reading that has the middle position in that set of values? So it's a little bit, it's actually very similar. If you think about the arrays or lists that we've been discussing, we can talk about values as being in a certain position within the array. So, the first element we know is position 0, position 1, 2, 3, 4, etc. All the way down here to position 36, because of course we started counting at 0. The median operates in a similar way where we say, okay, if I have 37 positions, what is at the halfway mark? And so we do this in exactly the way that you might think. You can take you simply take the number of entries that you have, which in this case is 37, and you go for the middle one. So one way to think about this is just to say you can divide it in half and then round it down. But basically, in the case of, and then round it down, and then you're looking for the sort of like the 18th or the 19th, the one that's halfway there. The way that I like to think of it that makes it not confusing for me is that the median is going to be the value in an odd number of data points. The median is going to be the value that has the same number of entries above it as below it, right? So in this case, that's going to be the 19th entry, which I think for us is going to be row 20. So the way that I do this is, let's see if this is telling me. So it's saying 18 rows, so that means row 20. Okay, so I'm just going to highlight this. Somewhere there's a format thing that lets me highlight it. Usually it's in a shortcut. Yeah, here we go. So I'm just going to highlight this yellow. Now, in an even number of data points, the way that I tend to do the median is I choose the two middle rows. In this case, it doesn't really matter, of course, because the figure is the same across many of them, across the adjacent ones. But basically, this is my midpoint. So the median value here, and it's exactly that simple. So the median is not the line number, it's not the position. It is actually the value that appears there. So in our case, it's 80,000. Okay. Now, obviously, to do this one, I'd have to sort it again. So I'm going to leave that. I'm going to leave that as an exercise for the reader right now. And we're going to end up dividing this up into a few more pieces in order to get a discussion of we now have two measures of central tendency. in the next video, what we're going to talk about is how we measure distance from that measure of central tendency. So already one thing you can probably see is that the figure that was talked about in January does not even appear in this data set. And so we're going to talk about how extreme we can consider it in that regard.